And today we have Ari Palo joining us and telling us a lot of stuff about CDK. But before that, I have a few things that I want to walk through. So, as always, we are a big bunch of local communities, and we did have the virtual meetup set up to, I guess, all sites in Norway, and at least in Finland, in Helsinki and Tampere, in Iceland, in Copenhagen, and from Sweden, at least in Stockholm. So we should be a good bunch of crowd tonight. We have enabled the event mode, so you are not able to unmute yourself at this time. If you need to communicate during the presentation, you can write down in the chat box, and or then when we are closing to the end of the presentation, we can disable the event mode and get everybody the possibility to also interact and ask questions from Ari directly. But for now, let's all stay muted so that we can concentrate on the content. So as said, the topic for today, Ari Palo from Alma Media is going to give us a CDK deep dive, and he will discuss more about how he has structured the agenda of his content, so you can then decide that what are the parts that are relevant to you, or if you need to step outside at some point. But at very first, I wanted to point out that there is a CDK channel now in the AWS Community Nordics Slack. So you are free to join that channel for continued discussion even after the session of today. Good. So until the things normalize, we will continue experimenting with the virtual meetups. And with the organizers of the local Nordic meetups, we have agreed that we will still continue working together as one larger community and providing you with content that can be a bit more exclusive and a bit more deep diving on these special times, and take the advantage that what we can of the situation. As always, we expect and we value feedback. So at your chosen channel, please direct that feedback to us, that what you would like to hear and how you experience the content which we are producing to you. All right, so please make a note of our website, and there is also the instructions how to get to Slack if you are not already there. Other events, as maybe most of you know, reInvent is going to be virtual this year. There's the URL to catch on the latest news about that event. As said, we try to do at least once a month virtual meetup. We don't have the next topic lined up as of yet, but follow the meetup.com groups, Twitter, and Slack for any local info on those events. Also, if you have a topic you would like to talk about, you're free to reach out and we'll set you up. That's it for me. So at this point, I will hand the floor over to Ari. So quick sound check. Can we hear Ari?
Yes. Hello, everyone. Can you hear?
Yes, we can hear. And
next thing, I'm going to put the screen.
Yep. And one last thing before handing it over is that we are going to record the session, but we're going to stop the recording before we release the floor to Q&A part. So just to inform you that at that point your questions or answers will not be recorded, but as said, feel free to join the CDK channel and Slack, and we can have afterwards more detailed discussion there as well. Good. That's it for me.
Yeah.
The floor is yours.
Can you see my screen?
Yes.
Yeah, okay, good. Yeah, well, before I forget, you were talking about, excuse me, sorry about that. You were talking about the events, so I wanted to mention the CDK Day on September 30th before I forgot about it. So definitely check that one out. Tonight in this AWS Community Nordics, we have a special edition about CDK. And before I actually continue with introductions, I want at first give you an overview of what to expect. So there'll be quite a lot of content tonight. The presentation is split to 4 parts. First, I'm going to introduce, first of all, myself, the company I work with, and how and why we use CDK. Then I'm going to actually tell you about what CDK is all about. So people who haven't actually used CDK before will get up to speed what it's about. And then we're going to actually build something, and we're going to build a serverless demo, and then we're going to look into a bit how you would make this kind of a multi-language construct, so how you distribute CDK components for multiple languages. And after the second part, we'll probably have a 10-minute break, so people can, go to the toilet and get something to drink and so forth. And after that, we're going to dive a bit deeper into various CDK concepts that are important to understand. And then look scenarios where, at least at first, it might look like that CDK isn't enough and how you might sort of resolve those situations. And the last part is some considerations regarding a bit more complex projects. So projects that have multiple environments and are deployed to multiple accounts and things like that. So, yeah, and at the end, there's a Q&A at least for a bit, because I won't be taking questions during the presentation because there's quite a lot of you online watching this, which is, of course, a good thing. And as you can see, I have a lot of content. So at the end, there might be, if I still have a voice left, so there might be time for Q&A, but let's see. But regarding that, I will be also taking questions in the Slack. So AWS Community Nordics Slack, you can ask there. And also, I recommend you to join the CDK.dev Slack if you haven't seen it. It's a pretty new Slack, but focused on everything CDK. And also, I will be sharing the various links and probably the slides later on in the Slack as well, in the Community Nordics Slack as well. But yeah, let's kick this thing going with introductions. First of all, Ari Palo was the name. I'm an AWS community builder focusing on developer tooling. I work at Alma Media as a lead technologist, been there for 9 years, a bit over 9 years. I write blog in aripalo.com. I've been using CDK from late 2018, so pretty early on. And my programming languages of choice are Go and TypeScript. And there's also my social media handles if you want to connect with me there. A bit about Alma is that we're a European digital services and publishing company. We, compared to some companies that have single product, we're instead a company that has multiple product families. So that's why we split into these 3 different business units, but there's also this Alma ICT department where I work in. So I work with shared services and data platform and single sign-on that are provided to each of these business units. Some key figures about Alma: 1,500 employees, around almost 300 people working with technology, so developers or other people working directly with technology. And we are based in Finland, or the headquarters is based in Finland, but also we have businesses in Sweden and Central Eastern Europe. And we've been in AWS since 2012 and started using serverless in 2016. And as you can guess from those numbers, we love serverless quite a lot. So if you want to learn more, there's a couple links I'll be sharing, one report from AWS and one podcast episode where we discuss our serverless usage. But that's for the introductions. The situation before CDK at Alma Media was something like that. Actually, in the right-hand side picture, there's the poor fellow writing his millionth line of CloudFormation, and he seems to have some snippets there in the top shelf that he might be copy-pasting at some point. And yeah, but CloudFormation is a good tool, and we are still using it heavily and will be using heavily. But also we're using a lot of AWS CLI shell scripts, of course, some SDKs. And we have, throughout the years, we have used SAM and Terraform, and actually Terraform is still used pretty successfully by one team. Some serverless framework, Ansible, and things like that. The point being here that from the start, like 2012 and going forwards, we have been using various configuration management and infrastructure as code tools. So a lot of experience with those. But in 2018, the CDK documentation said that don't use CDK in production. And that's something that the picture is about what will probably happen if you do use it. That of course wasn't in the documentation, but I added that. Then one of our business units decided that challenge accepted. That was around September 2018. They had their they had done their CloudFront plus WAF infrastructure setup with previously manually, which of course isn't a good thing. So a lot of work to maintain those because you have to click through the web console. And then they sort of thought that, okay, they have to do something else there. First, they considered using the CloudFormation, but they sort of ditched that idea because they thought that, okay, they have 10 plus setups or websites, and each of them have one or several CloudFront distributions. So it would lead to a situation that using CloudFormation and trying to aim for one template would result in a template that was like really parameterized. So it would be quite annoying to try to, maintain it. So they thought that, okay, they're gonna do something else, and they found out about CDK, and it worked perfectly for them because with CDK it's code and it's object-oriented programming. So they created these base classes which define the common components, and then you can just extend that common component, that base class, to the various products and do the modifications per product there. And they accepted the risk because they could just, build it with CDK, test everything works, and when it worked, they just switch the traffic to the CDK built versions of the CloudFront CDN. And it was used by some of the biggest websites in Finland. So one of the biggest ones was Kauppalehti, which is top 10 biggest Finnish website with about 2 million weekly visitors. And it's been running since then with CDK, pretty great. Then around the same time in 2018, my team was thinking about our tooling. It was at that point we knew that our focus was shifting to building more company-wide APIs and services in the upcoming years. So it was a good time to think about it. We had some experience with serverless. We wanted to adopt GraphQL, so AppSync in AWS. And then regarding tooling, we wanted to have less shell scripts and less AWS CLI aliases. And so sort of aiming for a single tool that would solve many of the things that these various scripts and things provided for us before. And then again, we wanted to have this to do less copy pasting CloudFormation around, because the fact was that even though you tried to have some kind of a parameterized CloudFormation templates that people should use to deploy some common stuff, it usually ended up that people didn't really want to maintain those. Instead, they just copy pasted them around and modified them a bit. So it was pretty, it wasn't a good situation. And we wanted a better developer experience because our team is, we're just developers. We're not really ops we're not really sysadmin minded people. We're more like developers. So we like to write code. That was one thing. So we considered first Terraform and SAM and also serverless framework as alternatives. We had done stuff with SAM a couple of projects, and it was great for serverless, but still it was YAML, and we wanted something more like code. And also, at least at the time, it didn't help anything at all with AppSync. So that was one thing. Then Terraform was actually, we had one team and still is successfully using it. And the HCL syntax felt a bit better than the YAML in CloudFormation, but still it was more configuration than code. Also, I guess this depends on who you ask. Some say that Terraform's biggest advantage is that it doesn't use CloudFormation, but I still really, well, not really, but I still like CloudFormation as a service because I'm really familiar with it, so I'm comfortable working with it. So that was one thing that I sort of didn't like with Terraform, and we had a couple bad experiences with Terraform. It was probably because just us that reason why we had the bad experience, but still that we had a couple of those. The reasons why we chose CDK were, well, autocomplete. Well, the main thing is it's code, so it provides the autocompletion and IntelliSense in your editor, and it's TypeScript, and we knew already. Well, we knew TypeScript already, and we knew NPM ecosystem already, so those were big benefits. And we really liked some of the features that CDK seemed to provide. How we adopted it was that around probably autumn 2018 or something like that. We heard about it in Twitter about CDK. We read some docs, examples, and even some source code, and thought that, okay, this looks cool. Then we did a small proof of concept, just API Gateway, Lambda, and DynamoDB to see how it all, fits together. And after that, we found out that the other business unit, Alma Talent, was actually using CDK already. So the CloudFront distributions I was talking in the previous slide. So that gave us a bit more courage to go forward with CDK. And then we did a bit more improved proof of concept that resembled more what we wanted to actually build. Then around November 2018, we decided that, okay, we're going to build this thing with CDK, because at the time it wasn't a mission critical project. So during December we did a lot of developing, and then early January 2019 we released it to production, and it looked something like that. That there was CloudFront and some Edge Lambdas and AppSync and some other Lambdas and secret managers, and then calling some various APIs, and it has worked well. It's still running in production, 150 million or probably 200 million AppSync requests a month, and works really well there. But that was 2018. Now the situation is a bit different. CDK is in heavy production use in Alma within multiple teams across the enterprise, and also people are using with CDK with different languages, TypeScript, of course, being the most common one, but still some Python and Java as well. And there's some emerging shared constructs and patterns. And on the right side, there's some of the AWS services we're building with CDK, but probably missing some from there. But some of you might be thinking that, okay, what I'm talking about, I've been talking about CDK a lot. So let's actually talk what CDK is. It's AWS Cloud Development Kit, which is a framework for defining your cloud infrastructure using familiar programming languages and built-in abstractions. And notable thing is that you can also develop these abstractions yourself or use open sourced ones or some abstractions that are shared in-house within your company. You can develop infrastructure with CDK using multiple languages, or you can choose what language you want to use. Currently, it supports TypeScript, JavaScript, Python, Java, and .NET, and I think Go is upcoming at some point. How that works is it uses this tool called JSII, which basically allows other programming languages to interact with your code, basically exposing JavaScript classes to other programming languages. So in, let's say, Java, you can call that, there's an example here, you can say new hello JSII class, and then call a method, say hello. And you're working in Java, but in the background, it will actually execute JavaScript. But that's a way to expose JavaScript classes to other programming languages. Then we take a look of some of the most important concepts of CDK. First things first, everything is a construct in CDK. They call these building blocks that you use to make your CDK application and CDK source code. They call them constructs. And that's CDK uses the object-oriented programming model. So it allows you to define your infrastructure as a tree structure, and the tree structure consists of these constructs. And when you think about it, this kind of a tree structure is quite good representation for your infrastructure, because when you start to think about it, you usually have resources that are somewhat nested below each other, and they have relationships and things like that that could be formed in as a tree. So CDK again is a tree structure of your infrastructure, or a representation of your infrastructure. The top level node is called app. That's the top level construct. App is a construct that holds everything together. So you put every resources below it. Then within app, you can have stacks, one stack or multiple stacks. And these map directly to CloudFormation stacks. And note you can also have stacks in single app that are in different regions as well. And then within stacks, you will have constructs. And these constructs can be either single AWS resource, or they can be sort of more abstract constructs that encapsulate a bit more complex functionality. This is another way to look at CDK construct tree, is looking like this kind of a more group presentation. So the outermost group is the CDK application that wraps everything in it. Then you have stacks within it, and inside each stack you can have these constructs. So in the left hand you have a construct that is just one AWS resource, so DynamoDB table, but then you can have a construct that wraps multiple AWS resources in it. So this is how you sort of describe your infrastructure in CDK in high level. So once you have this CDK application, we will actually later look how this looks in an actual code. But once you have this source code of CDK application, how you get from the source code to the actual provisioned infrastructure. Well, there's a CDK CLI tool, so command line interface tool, and that takes your CDK source code here on the left, and it executes it, and then it synthesizes it into this thing called Cloud Assembly. Well, what is Cloud Assembly? Cloud Assembly is just a bunch of things that will be deployed to AWS. Basically, it consists of CloudFormation stacks or CloudFormation templates, and it could be again one template or multiple depending how you define your application. Then it also consists of these manifest files, which are basically JSON files that contain some data that will be actually inserted into the template parameters during deployment. And if you have things like Lambda functions, like I have here, it will then take the source code of the Lambda functions, and it will create a zip archive of them here. And during deployment, it will also upload them to this S3 bucket it creates for you. And once you deploy it, the CloudFormation service will take in the template and start provisioning your infrastructure and using also the assets from the S3 bucket. So you can think of, like, I don't remember, was it some CDK core contributor or someone made this metaphor that you can think it as like almost like a CPU, that you have source code, you have compiler and assembly language, and then processor. So you can sort of think this process in that way. But anyway, the important part is you have some, usually TypeScript, can be Python or Java code that CDK CLI then synthesizes into CloudFormation on some assets and then deploys it using the CloudFormation service. The CLI, I would say the most important commands are the init, synth, and diff and deploy. Init is pretty self-explanatory. It will initialize a new project for you. You can choose the language, TypeScript, Java, Python, so on. Then you can synthesize. So again, synthesize takes your CDK source code and transforms it or synthesizes it into a CloudFormation template or templates and some asset archives and so forth. Then you can call CDK diff, which will actually give you a output that tells you what has changed. So if you have modified your CDK source code and you have already deployed a previous version, you can do a diff between them and it will show a nice looking diff of them. And finally, then you can deploy your CDK application. Let's do a quick demo. I call this a classic demo because I myself have shown this few times, and I know many other people who have shown it, but it's still one of the best demos to really showcase how powerful CDK is. So we're going to use CDK to create a VPC with public subnet and private subnet in each availability zone. And also CDK will create internet gateways, NAT gateways, and routing tables and everything for us. So let's take a look how that works. Let's see, actually, there's some, just checking that time is still running. I'm not talking to myself. Yeah, so I've actually, to save time and avoid potential network problems, I've already initialized a new CDK application. I've created a folder, went into the folder, and then run CDK init there. And I've also installed some dependencies. I will go back to this, what these dependencies are after this demo. But what happens during the initialization, CDK, let's clear this a bit. CDK will create this directory structure for you that consists of bin and lib mainly, and also a test folder. The bin folder actually is a CDK application, and it looks something like this. I've modified it a bit. I basically set the region and account and things like that. But there's the important part in the CDK application that it initializes a new CDK app, and then you also initialize some stacks which you assign into the app. So that's important. Then you have the lib folder, which actually contains your stacks. So the good practice is to keep the bin folder and the application quite lightweight, and then put most of your stuff in the lib folder. So in the lib folder, I have this base stack that CDK has generated for me during the init phase, which I can then now start modifying to create what I want to actually do. Let's see. So let's start actually building the VPC infrastructure. We're going to need to import something before we can continue. So I'm going to import this EC2 module from AWS CDK / AWS EC2 module. So this will give us basically every resource that lives behind the EC2 namespace. And now we're going to create an EC2 VPC with all the subnetting and things like that. So if you have done this with CloudFormation previously, you know it's going to take, a couple hundred, maybe 300 lines to get this highly available setup that I showed here, that you have multiple subnets, different types of subnets in each availability zone. What I need to do, I'm instantiating a new class from the CDK, EC2 module called VPC, and then I'm going to pass in the scope, which comes from the constructor, and then some identifier. I'm going to call it just my VPC, and I need to give some properties to the VPC, and what I at least have to give is some CIDR. So I'm going to just say something like this. Let's not think about it too much. But this actually, it's everything you need to create the VPC with CDK. I'm going to show you what it does. I'm going to call CDK synth. I also have a profile there. Let's put it a bit like that. So I'm going to synthesize the stack. And it will actually take a look, because I provided the profile and I'm configured the account and the region and the account ID there. It will make a lookup into the actual AWS account and detect that how many availability zones there are, and it will create so many. Again, if I show this, it will create for each availability zone this subnet setup, and we can see it in action using the VS Code has this plugin for CDK, which is really useful. So I definitely recommend you to download it if you're using CDK. So we can actually start investigating the structure of, or the tree structure of CDK constructs. So we can see it created 3 public subnets, 3 private subnets, internet gateway, and also other stuff here. Then I'm going to create a bit more subnets here, because if I want to modify the setup, you see there is a public subnet and private subnet in each availability zone. But what if I want to have more, let's say some isolated subnets here? So you can modify it pretty simply. You can just pass in some configuration here. I'm going to say subnet type. And as you see, while I type, the editor is all the time helping me with the setup. So I don't need to jump around checking the documentation that what the hell I'm supposed to actually put here. The editor is really supporting me here. Let's call it like that, like so. And then I can do some copy paste here and just change private and public and public. And then if I, let's say, want to have the most IP addresses in the private subnets, I can take the CIDR mask out and it will actually calculate the biggest possible subnet size or the CIDR mask for that subnet from the leftover IP space. And now once we refresh, you can see I have isolated subnets, public subnets, and private subnets. And we could run diff here and see what it will make. I don't have anything deployed in the account, so it will actually show just a lot of green values. So it will create a lot of stuff for me. I can put it to deploy. Let's see, it might take a while to deploy, so maybe we're not going to wait for it, but we can set it to deployment and see what happens after a while. So let's continue with the slides a bit. Yep. So you saw me using that EC2 module here. Too much happening on the screen at the moment. So I'm using this AWS EC2 module here. So where that it came from? Well, there's this thing called CDK Construct Library, which you can find. Well, can't remember the URL, but here's a link as well. But you can Google CDK Construct Library, or you can find it from CDK Docs. That's the official source of all the documentation of the different modules, and also the source of the official CDK constructs. So you will find all the various. This list here is quite long. There will be basically module for every AWS service. And once you install the module, you can start using it, and you install it by using your dependency manager of your language. Let's see if the deployment, yeah, it's still going on, but you can see it's deploying NAT gateways there, and again, creating all sorts of stuff for us, which is one great thing about CDK is that when you use these constructs, it will actually provide you with really sensible defaults. So you don't have to, again, think about the really minor details. For example, when creating a VPC networking, instead it provides you with these sensible defaults, which you can then configure if you want. If I would want to, as it's now creating where's my mouse? Well, my mouse is somewhere, but it's creating 3 NAT gateways here. But I could say it's a bit challenging without the mouse. Maybe it's yeah, it was the PowerPoint. But if I wanted to have just one NAT gateway, I could say NAT gateways one here, and it would only create one NAT gateway to save some cost for me. But again, the point is sensible default, so it defaults to this more highly available setup. Then let's continue building things. That was a really simple, at least with CDK, it was simple, 3 lines basically to create a VPC networking. But let's create something actual, some kind of application that does something in AWS. So we're going to build this serverless message processor, which consists of SQS queue that will send messages, or Lambda function that will read the queue and receive messages from there, and then write the messages in the DynamoDB table. And if you think about this, how this would look in CDK, we can take again the look of this, group representation of the construct tree. So we have CDK application, we have some stacks, in this case 1 stack, and then these constructs here. So let's build that one. But actually, before we do, we notice that the VPC demo stack has been deployed. So we can take a quick look to verify everything works. Let me go off screen for a second. Going to the right place. Yep. And once the VPC loads, you can see there's VPC demo, my VPC here created. And there's also those subnets created for us. So the 3 subnets for each type, isolated, private, and public, and each are split split across all the availability zones. And we can also take a look at the CloudFormation here. You'll see there's a VPC demo stack, CloudFormation stack applied, which is the one that CDK deployed, and it created various resources for us. But next, let's build something a bit more interesting. Let's build that serverless application. Again, I have a setup here which has been initialized already, and I've already installed some of the dependencies. So basically, I run CDK init here, and then I've also run something like npm install dev dependencies, and then bunch of dependencies. So I already have quite a lot of dependencies in the package JSON. I'm going to close those and clean up a bit here. First, we need to again import some modules here. So we're going to import, let's say, DynamoDB from DynamoDB. And then we are going to create a new table. So we're going to say DynamoDB and table. Again, we pass in the scope first and then some ID. This ID is just you can think of it as the reference in CloudFormation. It's not the real name for the table. Although if you don't specify an explicit name, CDK will use this as part of the name it will generate for the table. But I'm going to call this my table. And then I need to give some props at least for it. And where you find these props as well is the AWS CDK. Let's say I'm working with DynamoDB, so I'm going to Google the DynamoDB module, and this takes you into the DynamoDB module documentation. And they usually have in the overview section, they have pretty good examples for various use cases with the module. But I'm going to just continue with the editor because I like how the editor supports me with CDK. So I know that I need to create the partition at least. So I typed PA, so it gives me this partition key, looks correct. Then I need to pass in some values. I happen to know that it needs some kind of a name, and I'm going to call it, I have it here, timestamp. Let's not then get stuck with what my table design here, this might be a bad idea to use timestamp as the partition key, but this is just for demo purposes. And also the whole application is a bit silly. You probably wouldn't make this for real purpose, but this is just for the demo here. So now I have defined my DynamoDB table. I could give it also some kind of a more explicit name. So I'm going to call it, let's say, AWS Nordics CDK special here. Then I need to create Lambda function. Again, we need to import some code as Lambda from AWS Lambda. And I'm going to also import other modules here as well. I'm going to use SQS and then import Lambda source events. And that was something like SQS event source. Yeah. So I'm going to create a Lambda function here. Again, it requires some properties. So I'm going to say where the handler is. It's going to be index.handler and where the code lives. And I already have made this Lambda function here. So I'm cheating a bit. So it lives in lib.lambda. And it's a super simple JavaScript Lambda. It actually only reads the first message it receives from the body and then saves it into DynamoDB table. So super simple again, probably something you wouldn't do for production, but it fills our use case for this demo. And then I need to tell it what runtime it's using. So node 12. So now we have Lambda function. Then we're gonna create a queue. Again, scope, and then some ID. I'm gonna say just my queue. And that's for the queue, actually. So pretty simple to create a queue. Then we're gonna need to tell how these resources can interact with each other. So we need to define some resource policies. So I'm gonna store these constructs into a variable so I can reference them more easily. And queue. So I need to tell that the function can actually consume the queue. So the Lambda function can read from the queue. So CDK provides these super useful methods called grant methods, which make defining resource policies really simple. So I say that, okay, queue grant consume messages to function. So now the function can read from the SQS queue. Next up, we need to trigger the Lambda function from the queue. So how that would happen? Well, we can check the Lambda function. And actually, when we take a look, you can see add event source. Sounds about right. So we're going to add some event source for the Lambda. And then we're going to use this AWS Lambda event sources module here. So I'm going to say new SQS event source, and then I'm going to pass in the Lambda function. So like that, what I'm missing here, sorry, the queue, of course, like so. So now the Lambda function will be triggering from messages in the queue. And then finally, we need to configure the DynamoDB table. So again, we're going to grant some kind of access. We could give it a full access or read data, read write data, but actually we only need it to write data into the table. So we can just select the write data. And this is great because it's really easy to define this granular security. So no need to give more wider access than necessary. And finally, we need to give, so this is the Lambda function code. So it reads from the environment DynamoDB table name it will use for the operation. So we need to specify the table name. So we call function add environment, and then we say table name, and then we get the table name from table name probably, yes. So again, using the editor and the IntelliSense and type system, it's pretty easy to come up with what's needed. So hopefully there's everything. Let's see. Let's synthesize this first. and see if everything looks correct. Yes, now it is synthesized. Let's take a look in the CDK Explorer. This is always a good place to look first before deploying that everything looks correct. So yes, it has created table, function, and queue. We could go and take a look a bit about how the queue for table looks like. So you can see the partition key defined here as string and so forth. But let's just be brave and deploy this thing and see what happens. During deployment, it will ask if there's IAM related or policy related changes, and then it will show this diff view of what will be changed. So you then can approve these changes or say that, okay, this doesn't look okay, that let's not continue, I need to check that out. So again, makes using IAM a lot easier. But if you want, you could specify require approval never or something like that, if I remember correctly. And now it will not ask you about changes in IAM policies. Other way would be saying that it was probably something like wide and only or something like that, a parameter that will only ask you about IAM changes if the changes will mean that some resource will get more wider access than it had, or more access to some resources that it had before. But you can find all those while those deploy. I can Google the CDK toolkit CLI. I can't remember the URLs out of my head, so I need to Google. But you'll find this page which basically lists all the command that CDK CLI supports. So we were using the deployment there, and you can also see various use cases how you can use the CLI there. It's deploying. During the deployment, we can again go back to the CloudFormation. We can see there's a serverless demo stack deploying. Create is in progress. Some resources are already created. Some are still we're waiting for. It shouldn't take that long, so we're gonna probably just wait it out for a bit. Let's see. Well, I can then show a couple slides while we wait. So just to recap about the demo a bit, why I really like CDK is this granular policy control. So in my experience, CDK improves actually security because of these granular grant methods. Writing these kind of a really granular resource policies by hand using either YAML, JSON is really it's a lot of work, at least. And I personally, I hate doing that. And I haven't really met a person, at least so far, that says that he or she or they enjoy writing IAM policies or resource policies by hand. So that's one of the biggest wins that CDK provides. Also working with more complex scenarios where you have to actually form these policy statements by hand, it's still better, I think, than using JSON or YAML, because your editor again supports you, and you can just nicely reference the resources you want, and you'll get the editor will show if you have syntax errors and so on and so forth. So this is, I'd say, that one of the biggest wins when you start using CDK is that you'll improve your security. Also, one note about Lambda functions. So you saw in the code, if I can, let's see how this. You saw here in the code, I just passed in the directory where the Lambda function lives, and it's only JavaScript here that we don't need to, and it doesn't actually have even, it's using the native dependencies from Lambda runtime. So there's even no dependencies used. But if you would be using something like TypeScript, or maybe you would be using some compiled language like Java or Go, then you need to have some kind of build process for your Lambda function. So CDK can help with that. you can actually provide some options for the Lambda function definition in the CDK and specify that, okay, hey, build this Lambda function inside the Docker container. Here's an example where I built a Golang or Go function with a Docker container that contains this Go environment that's meant for building Go functions, and then I provide just an array of commands that will be run inside the container. And once I run CDK synth or deploy, CDK will actually call this Docker container and with those commands, and it will output the build binary. So the CDK can then use it for deployment. There's a link to a blog post that will actually discuss a bit more about this, but it's good to know that CDK supports this. Also, if you're working with, Node.js or like JavaScript or TypeScript-based lambdas, you can use also Parcel to bundle the Node.js dependencies into the function. CDK provides quite nice Node.js function construct for that. But you should be thinking that if your project is a bit more complex, that you have many Lambda functions, then it makes the deployment of your synthesization step slower, because it will each time build your Lambda functions. And when you're developing something and trying things out, it might mean that you don't necessarily want to build the Lambda functions each time. So it will make your deployment slower. And also, this doesn't support things like testing, which is, I'd say, pretty important, or local invocation. So if you want to get those things, you'll probably need to look elsewhere. But it's good to know that CDK supports this. For example, for some simple projects with one Lambda or some hobby projects, this might be a really good option to have. But maybe in the future, they'll provide a better developer experience for testing and local invoking Lambda as well, and selecting when to build them or not. But it seems that our serverless demo stack was actually deployed, so we can see if everything works, just to verify that CDK was working. So we're going to go to the SQS queue. There should be a queue. Yes, there is. Serverless demo stack queue. Let's send a message. Hello, AWS Nordics. CDK is awesome. Something like that. Let's send the message. And it should be written into the DynamoDB. Let's see what happens. Are the demo gods with us today? Tables. It was this one, AWS CDK. Was it? Yeah, it was that. So let's see. Items. And there it is. So everything works. So that was our serverless demo application. Next thing, what we could do is that we could sort of refactor this a bit. We could say that let's do it really quickly. I'm a bit behind on the schedule, but let's say something like message processor or something like this. And then I'm going to, just to be lazy, I'm going to copy paste things here. Then I'm going to export class message processor something, and also it extends CDK construct. So every construct you create will have to extend the CDK construct. Scope CDK construct ID string, and well, let's define some props. Let's call them. We're going to make an interface that'll take some properties. Sorry. Interface. Like so, I'm going to close something. Bit more space here. Like this. And now we're going to copy paste the function, the queue, and the assignment of permissions into this file, like so. And now it won't know about the table anymore because we're in a different file. So we're going to use it from the props DynamoDB table. and then I'm gonna just say props and props again. And after this, I'm gonna remove these ones. It was called message processor. I'm gonna instantiate it here. I'm gonna say just like that. Why doesn't it find it? Well, let's do it manually. Let's hope it finds it like that. Huh? Yep. And then we need to pass in the table there. So now if we synthesize again, everything should look almost the same, but now the implementation of the Lambda function and the SQSQ is behind this. Let's refresh this. Yeah. So now you can see there's the table and there's this MP message processor, and behind it are the function and queue. So this way we'll get to the point that we can actually start making this our own constructs. We did our own construct here, and we can start, maybe later we can start sharing them, and if needed, and if needed, we can also share them with that, in a way that even CDK applications written in multiple languages can consume them. We could also add some simple tests here. So when I ran the CDK init, it already created some placeholder testing for me, and I modified a bit so that I've already imported the stack I've created there. So there are many types of tests that we can do. You can find all the possible testing types here if you go to this AWS CDK assert module. So you'll find all the different types of testing you can do and the detailed examples. But let's just create the simple test here. I'm going to actually remove that one. Well, let's not remove it. Let's say, let's try something to a stack to have, well, I need to actually have resource. I always have resource, yeah, like so. And then I'm gonna just check it has what we created, let's say SQSQ. So I can provide then AWS CloudFormation resource here. If you take a look, I can actually ensure it's written correctly, but you can take a look of the CloudFormation documentation here, and you can see the namespace and the resource type here. So you can actually test that, does your stack have this resource, or is there a resource like that existing? And then we can run just tests. It uses the jest to run these tests. And let's see what happens here. This is basically synthesizing the CDK application into CloudFormation and then checking that if this kind of a resource exists. And as you see, it exists there, which is nice. We can also do snapshot testing. Because I'm lazy, I have it here already. What this does, it synthesizes your stack into this kind of it synthesizes your stack into this thing called snapshot, which is just a snapshot in time of what your stack looks like. And now I'm running it first time. I don't have any snapshots anywhere, so it will create the first initial snapshot for me. And once it has done that, I can then save those snapshots into the Git repository. You see it created this file for me. Now, if I do some edit here, let's say I'm gonna call the table name something else, maybe it should catch that if I run it again. Or if I edit any of the properties of these constructs, it will notice that, hey, something has changed. and then you need to manually accept the change. So that's snapshot testing. As you see, the test failed, and it shows that this string does not match. So this is a good way to start actually testing your infrastructure. And since CDK is just code, it's nice that you can use real like good software best practices. Let's continue a bit. As I said, we can use these or define these constructs in for multiple languages. I'm not going into detail with those because there's not enough time to go through this like really extensively. But I'm gonna just show you quickly. There's the JSII tool. It consists of several smaller tools that help you with compilation, then packaging those compiled outputs for npm, PyP, Maven, NuGet, and so forth, and then releasing to those repositories. Let's quickly just see what that means. Basically, we created this separate construct in the message processor already, but we could create the same thing in JSII. So again, I have initialized everything, installed some dependencies, and you can see in the JSII getting started, you will get all the steps required to initialize a project, but there's a couple configuration things required. Mostly to package JSON, you have to, again, I'm missing my mouse cursor. Maybe now, yeah. So you need to specify some things like targets that are you targeting Python, Java, and so forth. I'm gonna be really lazy and just copy pasting everything from almost everything at least from the previous implementation and something like that. And then I need to also get the interface, something like this. The names don't match at the moment, but let's not get stuck with it. And yeah, and when you're creating this just a construct that isn't a CDK application, you only have the lib folder, you don't have the bin folder. But let's run actually npm run build. Let's see what happens if I forgot something important. There's again, this is something that you most often need to think about. I'm gonna say I should solve it, I think. There's a lot of conventions over configuration in JSII projects, so you need to be careful about how you rename things. And one important thing is that you can only export classes mainly or interfaces. So interfaces and classes, but you can, for example, export functions. So everything has to be a class because again, that class will be interacted via another programming languages in future if you release this project. And then I'm gonna just run npm run package. And now JSII will go through my code and actually compile it for different languages. And I had configured it to deploy it for, sorry, wrong file, package.json. I had configured it to use Python and Java. So it will create me of course, the npm package and then Python PyP package and then Java package for Maven. And then I could go on and distribute those. It will output the files into this dist folder once it's done, but it'll take a while. So we're not going to keep waiting for it. So we're gonna continue and finish this second part because I'm already running a bit over time. Couple things still about writing these constructs for multiple languages. So the point was that, again, if I still show this, that once this one has been packaged, I can then publish these packages from these Java, JS, and Python folders to the Java is still building, but there's the JS and Python. I could publish these to either public or private repositories, and then I could install them using whatever dependency manager the project is using. there are some tools. I will again link these into the Slack later, but there's one tool called Delivlib, which creates this AWS code pipeline CI setup that builds, tests, and publishes these constructs that you make. I haven't used this one. I've used these release and superchain tools. Superchain is a Docker image that contains everything. It's a big image, but again, you'll need these. You'll need these like at least a Python and Java and .NET and Go and these environments if you want to actually build for all these environments. So this Docker image provides everything, and then the JSIR release is just one command that will actually deploy to Maven and PyPy and npm.js. I've used these to actually deploy to Code Artifact. So here's some old screenshot of some of the constructs that I've deployed to AWS Code Artifact. Currently, if you use the JSIR release, you can only publish npm and Python packages. The Maven integration with Code Artifact isn't working yet, but let's hope it starts working at some point. But yeah, that was a lot of content. Let's see. Yeah, now it has packaged. There's the Java, JS, and Python ones. That was a lot of content. There still seems to be quite a few people, luckily, online. So let's have a small break. So one thing I wanted to still mention about using the JSII was that it's just not for building your own multi-language construct. The whole CDK is powered by JSII. So if you go to the CDK documentation or the module or the construct library, which has the documentation for different modules and examples, so you'll find the different languages listed here. So you can check out, for example, the Python one. It'll give you a documentation about the CDK Python constructs. Again, you could, if you want to develop your CDK applications with Java, so you can check out all the Java classes and methods and so on. So the JSII is a tool that powers the whole CDK project there. Sorry about that. But yeah, let's continue with the presentation a bit. Where were we? Yeah, diving a bit deeper. So these are still, I'd say, pretty main concepts regarding CDK, or important concepts, but these are still things that you might not necessarily think about when you are starting with CDK. And it's really useful to know this rather well, especially if you're working a lot with CDK. So I do recommend for everyone to go and read the CDK developer guide. It has a fantastic section about these various concepts. Did someone try to? Well, I'll continue. It's hard to because I can't see the chat while I'm presenting, so just had to check out that nobody has said anything. So yeah, I'm going to go through some of the concepts here, and I'll start with context. So well, there's constructs, there are concepts, and there's context. So a lot of words that sound similar, but context is a way to pass in some kind of information for CDK application during its synthesization or deployment phase. So there are different kind of context values. You can first of all, there's context that CDK itself resolves during synthesization or deployment, and those are called lookups. When I created the first demo, the VPC networking, the CDK actually made a availability zone lookup into my AWS account, and as it was in Ireland region, it noticed that, okay, there's 3 availability zones available. So it made a VPC network that was highly available and spread into those 3 availability zones. If, for example, I would have been deploying into some region that only has 2 availability zones, it would have made only 2, let's say, public subnets and 2 private subnets and so on. So CDK does these various lookups for you in the background, but you can also call them explicitly. So you can, if you have, for example, created a Route 53 hosted zone previously, you can sort of bring it into your projects by doing this hosted zone from lookup, and then you'll usually give the hosted zone name, or in case of some, let's say you're looking up some kind of let's say for example SNS topic, you need to give the topic ARN there, and it will look up if the topic exists and so forth. But those are some things that CDK so kind of handles most of the time in the background. But then there's a way, there are 3 ways for you to provide some kind of a contextual information for a CDK application. The first one is that you can persist some values in the CDK JSON file. Always, I actually forgot to show this when I showed some code. Let's clear this. Here's our serverless demo. So I'm gonna clean this, too much stuff happening. So when we take a look at this project, when you initialize a new CDK application, it will create the cdk.json file for you, and it'll contain some information where the application lives, and then there's also some feature flags that CDK controls that what features will be used. But you can also write basically anything, any kinds of information into this context variable. So you could say, like, I don't know, AWS Nordics and CDK, whatever, or foo and true. So basically any JSON, at least in the TypeScript world, you can put any JSON structure there basically. And you can then commit this file into your GitHub repository or any version control you're using. And what this allows is that, again, you can persist various configuration information, for example, or basically anything. But that's persisted context. Then the second way of giving some context for CDK is using the CLI arguments. There's the context option that you can provide basically any runtime context. So key value pairs there. So you could say foo on bar, foo equals bar there, or something, whatever, basically during the CLI usage, and that's really useful for in CI servers or CI environment. You can give some, if the CI knows some information that the CDK application doesn't yet know, you can provide that in via those context options in the CDK CLI. I use them mostly for some various modifiers. So I'll actually show an example in the upcoming slides. Also, you can set context via this more programmatic method within your CDK code. So for any construct, you can say that, okay, no set construct, that's wrong, it should be context, and then some value. So that value will be then available for any construct below that construct you set the command. It's actually easier if I just show it so you'll know what I mean. So I'm here in the, let's clear a bit. I'm here in the serverless demo stack I've created, and there's the DynamoDB table, and then there's the message processor. So if I go in the message processor, I can here say that, okay, this and node is just, well, it's the actual construct node. You can access each CDK element. For example, the function, it has a node, and the scope that I'm working here has the node, and the node has various methods. So I can say set context, and then I can change whatever I want basically here. And this information is only available within this message processor. So I couldn't check. I could try to get it here, like node try get, not that one, try get context. I could try to get it here, but it will return undefined because it's defined in the like lower level of the tree structure. So that applies only for only for the children of that construct. So it would be available for the Lambda function and what have you if I define some constructs here. Then an example. Here's an example of persistent values in the CDK JSON. I use it quite a lot for things like accounts configuration. So I have 2 accounts usually that I deploy to. So I have account specific configuration. So I define them like so. So it usually consists of account IDs, direct gateway IDs, domains, CIDR masks, subnets, things like that, and maybe some information about the project and so forth. But this is everything up to you. You can set whatever you want there or not. But usually I'd say the CDK JSON context is a good place to store this kind of a configuration. Then I use the CLI context for, again, some kind of a modifier information. Let's say I'm running in CI. I know the CI knows that this environment is going to be or this time the CDK application is going to be deployed in the production environment. So it can set the context flag environment equals production. And then within the code, I can just check what is the environment value. So I first get it from the context, and then I check that does it match production, and then I do something with that information. But that's an example of a modifier context. Then I use these 2 together quite often. Here's a simple example how you might combine this. So I have some configuration, as I showed in the first slide, some kind of account configuration in the CDK JSON, and then I'm passing in some CLI context as well. So I'm getting the accounts configuration from the CDK JSON, and then the type of account from the CLI context, and then I'm just finding it by the key. So if it's dev, I'll get the dev account configuration. If it's prod, I'll get the prod account configuration. That's just one way of doing it. And then I can access, let's say, the domain of the dev account and so forth. That's just an example how you might use it. It's not you know, you don't have to use it like those, but it's just an example how you can combine these CLI and JSON configuration values. I actually don't know when this was released to CDK or how long has it been supported, but at least when I started with CDK, around late 2018, CDK didn't support CloudFormation parameters, and people were asking for them quite a lot. So at some point, CDK has, I probably should have checked, but forgot to check it. But at some point, CDK released the support to these CloudFormation parameters. But the thing is, if you're working with CDK, you probably shouldn't be using them because they are not really native for CDK. So instead, prefer using the context and other ways of passing, you know, values. For example, if you're just passing values from construct to another, then you definitely should be using interfaces. So passing props to different constructs and different stacks, that's the preferred way. But for getting some external values, prefer context, or you could, for example, look up some values from, let's say, parameter store or things like that. The reason why you should avoid CloudFormation parameters is that they are only available during deployment time. So they are not available during, you know, if you just want to synthesize your stack and see what it's about. And it makes things a little bit more complex as well. Probably the only time you should be using the CloudFormation parameters if you're, for example, working for some kind of a cloud governance team or something like that, that provides these base templates for other teams to use. So they provide these CloudFormation templates for others. Then it might make sense to use these CloudFormation parameters in CDK if you're using CDK to generate those base templates for others. But otherwise, try to avoid them. Then one important concept are tokens, because many values can only be resolved during deployment. So then there's a concept of tokens that, for example, when you're writing your CDK code, you can reference your, if you have, let's say, S3 bucket, you can reference the bucket name by saying my bucket name, so it gets the bucket name property from your bucket. But if you try to, let's say, console log it or print it into console, you'll get something like this. You'll get this token bucket name and some numbers. That's because the code actually doesn't know the bucket name beforehand. It'll only know it once it has been deployed and or during deployment when the CloudFormation service actually returns that value. So that points to a CloudFormation resource return value. So that's how it will get it. So the important thing to know about tokens is that you kind of can manage them as strings, but you can't. So for example, you couldn't do native like split for a token. So if you try to split it by, let's say, a dash, it will basically fail. Or if you try to split it by, let's say, dot, in this case, it would split the value, but the array of the after the split containing the values would make no sense. So instead, in those cases, you will need to use the CloudFormation intrinsic functions. So you need to call CDK FN split, and then that split operation will be actually done during the deployment. But you can use these token values as in string interpolation. So if you're, let's say, defining some resource name or description or whatever string value anywhere, you can use them as part of string interpolation. There's an example in JavaScript or TypeScript. So that works the similar way as it does in when you're working in CloudFormation in YAML. You can interpolate some values into string. That works fine, but you can't really, let's say, loop through values in your own computer without actually calling the CloudFormation service. So that's something that you need to bear in mind. Also, most of the lookups will return tokens instead of sorry, not return, but most of the lookups will require that you specify a concrete value instead of a token. So let's say your AWS account already has a VPC network, and you're building a new CDK application, and you want to use the existing VPC in your project. So then you need to call VPC from lookup and then some parameters, either the VPC ID or the VPC name. So one thing I have at least stumbled upon 2 times is that I actually have stored the VPC ID in a parameter store. And then I thought, okay, I'll get the VPC ID from parameter store in CDK. But that didn't work because the value received from parameter store is actually a token. So it doesn't work like that. So VPC lookups, for example, they need to have concrete values. So you need to really have the hard-coded VPC ID string, for example. And this applies to several other lookups. So it's important to know that the concept of these tokens, that sometimes you can use them pretty straightforwardly, but still they are, CloudFormation resources. So you need to sometimes use these CDK FN, so CloudFormation intrinsic functions, and also remember that when you do lookups, they need to have real values, not tokens. Then this, I think, is pretty new feature called aspects, and this is a way of defining some. Usually, it's some kind of validation, for example. The example here is from the documentation that you define this class bucket versioning checker, and it implements this interface called iAspect. So you apply this bucket version checker to your stack, and then for each construct within that stack, it will actually visit, as it says, public visit, called that method there. It will visit every construct beneath that stack and check that if it's, in this example, if it's a type of S3 bucket, it will check that if the version control is enabled, and if not, it will set an error to that construct, and that way your synthesize operation or deployment will fail, and it will detect that, okay, something is wrong. So this is good way to sort of define some kind of a custom validation or things like that. And I could think of several use cases for this, but important thing to understand about this, that this doesn't necessarily replace like other guardrails in your AWS account. So if you define this kind of a, let's say, bucket versioning checker or some, bucket or public to the world checker or something like that, it won't, of course, guarantee that the developer, for example, wouldn't remove that aspect of that version checker or is bucket public checker or what have you. So it's not the definite guardrail, but I think them as this kind of a soft guardrails, that because they give a nice sort of developer experience, that you apply this aspect into your code and it will give you errors directly in your console while you're developing your CDK application, instead after you have deployed your setup into AWS account. So I think aspects could be really useful for these kind of a soft guardrails that sort of guide the developer to best practices. Then really important thing to understand about CDK is that there are different kind of constructs and they have different kind of stability levels. So first of all, there are low-level and high-level constructs. I have actually, when I defined this, let's go to this one. Let's take, for example, this SQSQ I have here. I'm using a high-level construct. This is sort of, some say level 1 construct or level 2 construct. But anyway, it's a high level, it's a CDK construct. It's more native to CDK. And as you see, it's pretty simple. It's one line. I'll just provide it with the scope and some ID. But if I need some other features that this doesn't provide, I could also use SQS CFN queue. So every construct that starts with CFN is a lower level construct, and it maps directly to CloudFormation resources. So I could use those. But the important thing to know about CFN constructs versus CDK higher level constructs is that the CFN constructs are, as they map directly to CloudFormation resources, they are automatically generated from CloudFormation resource specification. So they are more up to date usually, and they are also stable. So if there's a new feature in CloudFormation that CDK construct doesn't yet support, you might want to check out that if you absolutely have to use the new feature, that's one way. But there are other ways. I will come to those a bit later. But that's one way of getting that new feature, by using the CFN resources, and also they are stable. Some CDK constructs, as in the example here, the RDS module, there the CDK constructs are in developer preview. And constructs that are in developer preview or experimental, they don't follow semantic versioning. So there might be breaking API changes between minor versions. The developer preview ones are usually a bit more stable, that they won't make change unless absolutely necessary, but they might do it, and they have. But there's also experimental ones that will probably break at any given time. So be careful, or not necessarily, well, of course be careful, but be at least considerate that what resources you are using. When you go to the construct library documentation, you'll see these stability patches everywhere. So just bear in mind what kind of a constructs you're using. many times, nowadays the situation is rather good that at least most popular modules are usually in stable or at least developer preview level, but there are still some experimental modules, and again, the developer preview modules can also change. So if you want to use those non-stable modules in production, should you? Well, I'm not going to answer that should you, but you could at least. And for example, we do. But it's important to understand that it has an effect that when you update your CDK version or the version of all the CDK modules in your project, you need to make sure that the update didn't break anything. So how you do it, you write those tests, so you can test your constructs, you can even test your snapshots, stacks, and just write a lot of tests. So that will cover something. And also when you have updated CDK, and if you know you're using experimental or developer preview versions, just make sure that, okay, synthesization process completes okay, and it's when you deploy to some kind of a testing environment, make sure everything works and so forth. But that's just, good practices anyway, that if you update dependencies, you should make sure that everything works as expected. So keeping up with CDK versions, then that's actually can be quite frustrating sometimes. They are releasing new versions weekly, sometimes more often, and they say that they're going to probably aim for releasing each day or something like that. So there's a new versions coming all the time, which is actually a good thing, because it means that it's in active development and they are creating new features and so forth. But CDK actually is something that they call hypermodular. So if I look at the package JSON, this is actually better. So you can see each AWS service is a module, just to sort of simplify a bit. But in a complex application, you might have several tens or more, even more of these modules here as a dependency. The challenging thing is that you need to keep each one of these in same version. If you have, well, let's say if you would have something like 1.50 in some of these modules, there might be problems that the stack or the application won't even synthesize because there's some interface isn't implementing some specific field or something like that. So you need to be careful that you need to keep these in same version. And one way to manage that is using Renovate Bot, which is you can get it from GitHub Marketplace. GitHub provides this Dependabot feature that updates your dependencies via pull requests. But unfortunately, at least at the moment, Dependabot cannot handle these sort of monorepo projects that have multiple dependencies that need to be updated at the same time. But luckily, the Renovate Bot does. So this is pretty useful. So I've started taking this Renovate Bot to use in my CDK projects. And you need one configuration. You'll find this from Renovate Bot documentation, that you define CDK as monorepo. So after that, the Renovate Bot will create pull requests that update all your CDK dependencies at once. So that's super useful, staying up to date. Also, we have in Alma, we have defined this or created this Slack channel that basically gets the latest feed of CDK releases. So people who are working with CDK are kept informed about the latest changes and latest versions. Well, there was a lot, but about if you are working with CDK or starting with it, and even if you have worked with CDK a while, it can be hard finding good examples and good patterns, because even though CDK has been available over 2 years now and it's been in general availability for 1 year, it's still a pretty new thing, and the best practices and patterns and things like that are still emerging. So some things I'd recommend are checking the AWS official resources, which is of course the official examples, and then there's this solution construct patterns library, and there's some specific use cases. Some of them are pretty simple, but still you can get the idea how you can put together CDK applications and some patterns with them. And then there's also cdkpatterns.com website, and it's a nice resource. You can, for example, find patterns implemented in CDK that reflect some AWS well-architected pillars, and also you can find by AWS resource types and so forth. So definitely check those out, and I again will send the links later. On a previous slide, I mentioned about CDK being hypermodular, that it has multiple dependencies. So related to that, the future of CDK looks something like that. It's currently in 1.60 something version, and they're thinking about releasing version 2 probably within 6 months or something like that. No one really knows yet, but that's the latest estimate I've heard. And I think originally there was supposed to be even more breaking changes, but I think mostly it's been just removing deprecated APIs, and they've been pretty successful in developing new features and sort of modifying existing functionality within the version 1 major version. But there will be version 2 new major coming at some point, and one of the biggest things I wait from it is that it actually provides the whole CDK as one monolithic library. So you would be able to just install, AWS CDK and then use all the modules from there. That would be super useful. Then a few words about when CDK can be challenging, or when it feels like that CDK can do something for you, and how you might resolve that situation. In some tools that provide some kind of abstraction layer like CDK does, the challenge, I think, is that when that abstraction layer fails for you, you're out of luck, that you need to ditch the whole tool and change your tool chain totally. But the thing I like about CDK is that you can always sort of drop down a level in the abstraction layers. So you use those higher level CDK constructs like that SQSQ one, which provides like single line SQSQ definition with all the sensible defaults. But if there was some feature that it didn't support, you can always define the queue as a CFN resource. So here's an example. Sometimes there are resources that aren't supported as the higher level constructs. One example is the web application firewall. It only has the CFN rules. So one thing that we do quite often at Alma, that we have, we develop a lot of websites and web APIs. So we might have, staging version that's pretty close to the production version, but just something we want to check out before we actually put it to production. But we don't really want to expose it to, to internet, that if some customer accidentally access the staging version, they might be confused. But so that's why we use WAF in some cases to manage this, that we block some block the requests that don't come from the company. And so I use WAF quite a lot, but unfortunately that doesn't provide a high-level construct. So I have to use these. You notice the CFN prefix here. So I'm using this map directly to CloudFormation resources. Of course, if I use this quite often in several projects, nothing is going to stop me from creating my own construct and wrapping these within that my own construct, and then publishing that to, let's say, AWS code artifact for TypeScript and Java and Python, and then installing it via dependency manager to my various projects. Nothing is going to stop me from doing that. But it's just important to note that some resources don't have the higher level constructs. One example is another example is constructs that have both ones, but the CDK construct is not stable, it's experimental. So you might want to use the lower level construct if you aim to have only stable stable constructs. The one example is the SES resources, that there's some experimental versus some stable constructs there. But in most cases, if you're working with higher level construct and it just doesn't implement some specific feature like you want it to implement, or it's missing some new feature, then there's these things called escape hatches. And escape hatches in CDK mean that you can define your resources in the higher level constructs, but there's a way to sort of access the lower level resource and then modify the CloudFormation attributes directly. There are a couple examples that you can sort of cast this bucket high-level resource into the lower-level resource and then access some properties in there. And you can access it by this node attribute again, and then find the default child, and that's actually the CFN resource, and then you can modify its properties. Or you can use this add override or add deletion override or add property override and so forth methods, and these allow you to again set some direct CloudFormation properties. One place I've actually used it latest was RDS cluster, that the higher level database cluster construct didn't support enabling IAM-based authentication on the cluster level. So it only supported with instances, but I wanted to enable it on the cluster level. So I just used these overrides there and said that, okay, enable YAM authentication true. So that solved that problem. When everything else fails, basically when CloudFormation fails for you, the classic thing to manage this situation when CloudFormation fails for you is using custom resources. But they are something that if people say that you can use custom resources for that, you usually just run away, because defining custom resources can be sometimes painful, but at least in manual CloudFormation. But with CDK provides these AWS custom resources, and and they are especially good when you need to sort of monkey patch some missing feature in CloudFormation itself. This is an example where I am creating a direct gateway association on stack creation, or actually I'm creating a proposal for that association, and then on deletion, I'm removing that association. So that's not supported by CloudFormation, but I can use the CDK AWS custom resource for that. And how it works, it makes actually a Node.js Lambda function that has the AWS SDK in it, and you can just specify what service, what action, and what parameters are used, and then it calls the AWS SDK, and it'll in this case it'll create a direct connect gateway association proposal, and then I just go to the another account to accept that proposal maybe. And these are really useful. Again, don't make custom resources unless you really need them or really want them. But if you need or want, this is a good way of doing them. Then the final part, again, I'm sorry, I'm really over time, but luckily this, even though this is a complex subject, I won't have that much about it. So this is the final part. And I want to clarify something, that the things I'm saying or showing here are just sort of how I'm doing things, or some ideas how you could be defining your projects with CDK or using CDK in your projects, because the truth is that every company or team and project has their own requirements and conventions and use cases and so on. So do not take this as a gospel, but take this as something that you might or should be considering when you create a bit more complex projects with CDK. And what I mean with complex projects are something that have at least multiple accounts and multiple environments. And then within each environment, there are a lot of different resources and maybe a lot of different stacks. I use this model that each product or product family, depends on the case, has two accounts, production account and development account. And in each account, there's all these account resources as seen here, usually just VPC and maybe direct connect and maybe some hosted zones and things like that. And the same goes for the production account. These are usually pretty much similar setups here. Then production account can contain one or two environments. It always contains a production environment, but it can optionally contain also a pre-production. And then dev account contains development, at least staging, maybe some dynamic feature environments that are only temporary. But regarding that, I have for my team developed this CDK construct that sort of enforces this account and environment pattern. So CDK can be useful for enforcing certain conventions in your projects. So I use this, I define what environments can be on what accounts. So this construct takes care of that. Then I showed this already previously, but I have the account configuration in the CDK JSON in the context. So I have all the account IDs and things like that there easily available. And then in the, let me check, there was some message, I think. No. Then in the, then I can also pass in the environment, usually within the CI. So I can pass in things like, is this a staging environment or is this a production environment and things like that. So I showed a bit similar example already previously, but this is just one way of getting your, let's say you're defining code or application that will run on two accounts. So again, you can have the two accounts configured in CDK JSON. Oops. And then you just choose which configuration you are using. About CI/CD with this kind of a model, one thing I wanted to say that CDK CLI is nice because you can specify these wildcards, so you can only deploy parts of your application. And I use naming conventions in the CDK stacks that these account resources, the stack always has the string account in them, and environmental resources always have a stack name containing environment. So I can deploy an environment, or I can deploy an account resources, or I can just deploy, let's say, some database stack. So these are pretty nice way of filtering what you want to deploy at any given time. Then I'm not going to dive deeper into the CI part, but just wanted to, because this doesn't really relate to the CDK per se, but people often ask me how I deploy CDK applications in CI. So just wanted to quickly say that, again, I have those account and environment context variables that I specify in CLI. So they choose to which environment and to which account CDK deploys. And then the CLI knows that in which given time, in which given sort of context, it will set to which values, these context values. If I'm on a master branch, then it will set the account as dev and environment as staging. If I have a Git tag, so it's a release, it will actually set the environment as production and so forth. So this is sort of the deployment flow. I won't go through this now. I'll actually have published this in my blog, so I can set a link to it if you want to learn more about it. But just to say that there's probably a million ways you can deploy CDK applications in CI, but this is just one way of doing it. And the nice thing about this that I get these feature branches, or feature environments, that if I have a specific prefix in Git branch name, it will deploy a new dynamic environment, so I can play around and try new things easily. Especially good with serverless. This slide is because quite often people have asked from me that, do I trust CDK for deployment? That they are scared of letting some new tool deploy their infrastructure. And they are thinking that, okay, they would rather still deploy using the CloudFormation template. That is, of course, possible in CDK, but you'll need some tooling to wrap because the template is heavily parameterized that the CDK generates, so you need some kind of tooling to map the arguments or the inputs into the template, and it's a lot of work, so I don't necessarily recommend that. And anyway, CDK is a nice tool for deployment, so I'd really like to use it. So people who are sort of scared about the idea of CDK deploying their infrastructure is the couple things I want to point out, that if you are using multiple environment, that sort of brings safety to the whole thing. That first of all, even before going to AWS, in my team, the developer can execute the Lambda functions locally using Lambda CI, Docker Lambda, so they can sort of test the Lambda application logic. Then they run tests for the Lambdas, and if you have some other, let's say, some containers or what have you. And then for the CDK, they can run tests again if there's like snapshot tests or unit tests or any kind of assertions with the CDK assert library. And they can also synthesize the stack and see that the synthesization operations succeeds, and they can do diffs, so they can check that what will be changed if I would be deploying this to some environment. And optionally, there's a development environment where anyone can just try things out and deploy random stuff. But that's all happens before even deploying to an environment. So after the code is pushed to GitHub, it will, of course, lint and test and build and what have you. Then if it's a feature branch, it will go to a feature environment. You can test your changes there. Once it has been tested there, you can create a pull request and merge it into a master, and that means it goes to a staging environment. And if you want, you can still test it there. Often we still commit to master directly, and it will go to staging directly. But especially for bigger features, you can use the feature environments. It's a good thing to do. And with serverless, that's easy and cheap. If you have a lot of EC2-based workloads, using feature environments is probably impossible even for you. But again, once it's tested in staging, it goes to probably pre-production if there is one, and if that deployment succeeds, it goes to production. What I'm saying here is that having multiple environments bring this safety that you can test it in many places before actually the code goes to production. Then one thing I do is that, because I separate these account resources and environment resources, so one thing I do in CI is that I don't actually deploy the account resources, but I do a diff against them in each CI build. So I diff against the account resources, and if there are changes, the CI process will fail. So that ensures that we keep the account resources up to date because they are deployed manually. So if you don't deploy, they would sort of become old or not relevant, and you might have done a lot of changes into the account resources, but you don't actually remember that, hey, they aren't deployed at any given time. So this is a good pattern to just check that there isn't any unexpected changes for account resources that you should be actually then deploying manually. But the environments are deployed automatically. And then one thing you can also do is that if you really want to have a lot of control on your deployments, you can also set this execute false option in CDK CLI. What I'll make is that it'll create a deployment, but it won't actually execute a change set. It will just create a change set in CloudFormation service, which you can then go and you can just check out the whole change set in CloudFormation web console, for example, and see what it's creating, or create some automation to ensure that the change set is valid. And this can be really useful for those who want really tight control on what to deploy into production. But I'd say that, again, this can be challenging because this will create change set for each stacks in your CDK application. And creating multiple stacks in CDK is quite easy. It's quite common that projects that my team does have, let's say, 10 stacks or more. So it would mean that you would have to check out the change set of each 10 stacks if there are changes in each of the stacks. So it's up to you if you use this or not, but personally, I'm not using this. But again, because there are multiple environments and other processes to prevent accidental changes. And if there are accidental changes, then you can always roll back or make a quick fix or what have you. Another way of managing accounts, I haven't used this, but I've felt that I have to show this here, is there's a new plugin called Assume Role Credential plugin, and that allows you to define multiple accounts in one CDK application explicitly. So you'd actually import your stacks multiple times and define just different accounts there, and CDK will then assume roles to those accounts and deploy the stacks into there. But I don't personally use this, and one thing I do is that I define my stacks and resources once. So I only control that to which account and environment they are deployed by using those modifier values via context. So that's how I do it. But this is definitely a way for some people that they would really benefit from. So depends on your use case. Then a couple notes before we end this. Again, sorry, a bit over time, but hey, you're voluntary listening to me, so I'm not feeling bad about this. But when you're defining a bit more complex projects that have multiple stacks in one application, think really carefully about the dependencies between the stacks, because CDK is super awesome that it's really easy to reference values between stacks. In the background, it uses actually CloudFormation stack exports and imports to do this. But when using it from the, for example, from TypeScript code, as is this example, it's really easy just to expose some, let's say, VPC as a public read-only interface from the network stack, and then pass it to that database stack as a property, like so in here. So it becomes easy passing around these references to different resources, but it can lead to this sort of problematic situation that everything depends on everything, and that's that's bad, because when you want to modify or even delete some of the stacks that you have in your application, you might end up in a situation where you actually can't do that because there are different dependencies between the stacks. Of course, CloudFormation can spot cyclic references, but if you have multiple stacks depending on like you see on the picture on the right-hand side, it can be really challenging. I've heard cases that people have ended up in a situation that they need to create temporary stacks that use and expose those values to other stacks, and I don't know how they survived that. But that's not a problem of CDK, that's a problem of misusing CloudFormation features, but CDK again makes that easy. So be considerate on how you use this. But you definitely should use this, and you definitely should use different stacks to do different things. That's a good thing. I again, as I said, I have projects that have even over 10 stacks in one application or more even, and they might have nested stacks and things like that. And also, when you expose values, use the interfaces, or prefer using the interface versions of the references instead of the actual constructs, but when possible. But that's not always possible, but just a one tidbit there. And when you have a bit more stuff in your project, it's always important to organize the code. Again, CDK's code, and you should organize it somehow. Instead of, usually you might have had one CloudFormation file, which is long as well. It can be several hundreds or thousands or what have you lines long if you write everything into a single CloudFormation file. But in CDK, it's easy to split things into smaller pieces. But even if you have a more complex project, I recommend keeping the default top-level directory structure of what CDK creates when you initialize a new application. So it'll make everything a bit easier for people who are just coming to a project if they know CDK beforehand. Also, it sort of enforces you to think that the app lives in separate place. So it means that you should always, when you're working with the app, you should keep in mind that keep the app really lightweight, that don't put much logic into the app. Most of your infrastructure logic should be in the lib folder. But in the lib folder, there's one example of another project that has this account and environment split, and I have defined various things behind this. I have quite a lot of subfolders there, but I like to as CDK's tree structure. I also like to make this quite verbose directory structure to sort of organize things, but that's up to you. But whatever you do, remember CDK's code and use, organize and name things in meaningful ways. So especially when you're using serverless and managed services, that means that your infrastructure code is basically your business logic. So name things in more businessy way, let's say, that instead of naming stacks and files with like referencing to AWS resources or putting everything into a single file, you probably could reflect what the business problem it's solving in the let's say in the construct name and in the file name. I like that approach. I'm not saying it works for everyone, but it has worked well for me, and I can even change the technologies behind some sort of business problem in the infrastructure code, and I don't have to rename everything. And also, when you split into smaller files, it makes testing a lot easier, and it's easier to refactor them as separate constructs that you publish separately. So this is pretty much it. I'm quite a lot over time. Sorry about that. Hopefully there's even somebody listening. I don't see the chime here in my screen, but just to recap CDK's code. So use good software development practices and think about how you organize your code, both in file system and both within the files, how you manage dependencies, versions, testing, deployment, these kind of things. Use and learn from the patterns provided by the official examples and the solution constructs and patterns, cdkpatterns.com and so forth. And remember that it's an abstraction layer for CloudFormation. You need to still know something about CloudFormation. You don't necessarily need to know that much about all the details of CloudFormation, but still you sometimes need to check out the CloudFormation documentation. But the power of CDK is that it makes developing with CloudFormation so much faster. That was it about the content. I'd say since we are quite a lot of overtime, I might take few questions, but again, feel free to ask in the Slack. So in the UG Nordic Virtual, I'll try to answer probably not tonight, but tomorrow latest, and I'll be sharing the links and resources there. And feel free to follow me and Alma developers in Twitter if you want. So. There seems to be still a few people.
Yeah, big thanks to Ari. I think that this was like an awesome session with so much detail about the CDK.